AI models are updating every few weeks. Timelines for artificial general intelligence are moving closer. Shopping is shifting to autonomous agents. Solar and wind are overtaking old energy sources. Cancer detection may soon fit into your pocket. Every breakthrough we see, from LLMs to renewable grids, is colliding into a single system of convergence. Multiple exponential technologies are now reinforcing each other, arriving together as a stack of breakthroughs. We often struggle to track this shift because we rely on outdated metrics. When every top AI model starts scoring perfectly on known tests, those benchmarks lose their ability to show us what is actually happening. Understanding this new reality requires looking past individual industries and analyzing how these exponential curves collide. Anthropic recently released Opus 4.8, reclaiming a key coding benchmark lead from GPT 5.5, shortly after the release of Opus 4.7. The interval between major AI updates has compressed from annual cycles down to a monthly cadence. This speed is causing standard benchmarks to saturate. When an AI can ace a bar exam or a medical test instantly, the test itself stops providing a useful measurement of top-tier capability. Measurement is shifting toward a new frontier: discovery. We are looking for AI that can solve unsolved scientific problems and create knowledge that didn't exist before, rather than just reproducing known answers. The current race centers on model orchestration. The core differentiator is now a system's ability to build, debug, coordinate, and manage highly complex work autonomously. This level of orchestration requires physical power. Intelligence abundance relies entirely on a corresponding scale-up in energy. Renewable energy deployment is following an exponential curve. Recently, global electricity generation from solar and wind crossed a major threshold, surpassing natural gas. Advanced compute is also industrializing. IBM and the US government are developing a dedicated quantum chip foundry. This moves quantum computing out of the experimental lab phase and into a manufacturing infrastructure. If quantum processing begins to accelerate material science or chemical simulation, domestic supply chain control becomes a national priority. Real-world industrial scale in power and manufacturing is what keeps the intelligence revolution from stalling. Built on top of that infrastructure is the intelligence layer. Predictions for artificial general intelligence are tightening, with DeepMind CEO Demis Hassabis and other experts moving their timelines closer to the year 2029. The debate over AGI remains complex because the definitions are shifting. Experts are split on whether AGI means passing exams, discovering relativity, or demonstrating broad reasoning across physical and digital tasks. Today's systems are demonstrating early versions of this capability by managing many parallel tasks simultaneously. They are moving from generating text to orchestrating entire workflows. AI is becoming an infrastructural brain, a utility that manages complex systems and serves as a foundational layer for modern civilization. We see this intelligence layer moving into commerce. Amazon is embedding AI shopping assistants into retail, while Google builds open protocols for agentic commerce. As these systems move from answering questions to executing transactions, your personal AI will compare prices, negotiate terms, and finalize purchases for you. This forces a shift in business strategy. Consumer brands will soon market their products to personal AI agents that make decisions based on data and logic, rather than marketing to humans through traditional ads. The exact same convergence is now hitting healthcare. Researchers are discussing a pocket-sized optical sensing device that could detect early-stage lung cancer from a single drop of blood. This application layer turns abstract code into a practical tool that democratizes diagnostics and rewrites the rules of global markets. Governments are realizing they need faster feedback loops to handle this transition. California has initiated a program to track AI-related workforce effects in real time to build better early warning and retraining systems. Rapid shifts in labor and technology create friction. We are seeing organized hostility and anti-tech extremism directed at industry leaders as societal concern grows over the speed of change. The data centers housing this intelligence require massive security. These facilities and their dedicated power substations have significant physical vulnerabilities and are increasingly treated as critical national assets. If progress creates widespread fear, the primary threat to innovation becomes a breakdown in public trust rather than a technical limitation. As AI and quantum systems create enormous global wealth, the core question becomes where that value is actually distributed. The foundation linked to OpenAI could become one of the largest philanthropic entities in the world due to its ownership stakes. This places massive financial influence in the hands of a single mission-driven organization. This leads to proposals for systemic wealth distribution, public wealth funds, universal basic income, and universal basic compute, access to the processing power driving the economy. In an era of technological abundance, the priority shifts from production to the equitable distribution of resources. You can prepare for this by changing how you use these tools. Stop viewing AI as a curiosity. Focus on tracking agent workflows and building skills around orchestration, judgment, and learning speed. The convergence of intelligence, energy, health, and commerce is creating a new operating system for civilization. Future success belongs to those who can navigate this unified stack rather than tracking individual tools. The future is accelerating. The challenge now is to become the kind of person who can understand it, use it, and help steer it well.